Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In lower classes, we studied about metals and non-metals, synthetic and natural materials, acids and bases, etc. All the metals and non-metals, synthetic and natural materials, acids and bases are the examples of matter. Water we drink, food we eat, air we breathe, clothes and various things that we use in our daily life are the examples of matter. Let us know more about the concept of matter scientifically. Matter. In a simple way, anything in this world that occupies space and has mass is considered as matter. Everything in our world is made up of matter. The scientists work on stuff. Even the air around us is matter, although we cannot see it. All the things around us which exist in a variety of shapes, sizes, and textures is matter. There are three states of matter called solids, liquids, and gases. Matter can be changed from one state to another, like a solid to a liquid or a liquid to a gas. Let us study about the physical nature of matter. The nature of matter can be determined by studying its properties and composition. Similarly, the physical properties of a matter can be observed or measured without changing its composition. The physical properties of a matter basically mean its color, smell, density, melting point, and boiling point, etc. Here let us perform an activity to decide about the nature of matter. Is it continuous or particulate? Click each tab to know more. Take a 100 ml beaker. Pour 50 ml water in it. Mark the level of water. Add 2 grams of sugar into the beaker and stir it with a spoon till all the sugar gets dissolved. Observe any changes in water level. We will observe that the level of the water in the beaker is at the same mark, where water level was initially in the beaker, after dissolving the sugar in the beaker. From this activity, we learned that even after dissolving 2 grams of sugar in 100 ml of water, the volume has not increased. When we dissolve sugar in water, the particles of sugar gets into the spaces between particles of water. Hence, we conclude that each sugar crystal itself must be made up of millions of small particles. In the same way, dissolving sugar in water tells us that there are spaces between the particles of water. The following are the important characteristics of particles of matter. They are: the particles of matter are very, very small. The particles of matter have spaces between them. The particles of matter are constantly moving, diffusion. The particles of matter attract each other. We will perform some simple experiments to show all the characteristics of the particles of matter in a later session of this module. States of matter. Water can be found in all 3 states. Because of this, we can say that solids, liquids, and gases are 3 different states of matter. Click each image to learn more. Solids have a certain size, shape, and volume. In this state, the constituent particles are closely, regularly, and tightly packed. In the same way, the particles cannot move around much, but these particles only vibrate in fixed positions. Liquids have a definite volume but no definite shape. In this state, the constituent particles are not together closely. For example, milk is a liquid matter. It has a size or volume. Volume means it takes up space. But milk does not have a definite shape. It takes the shape of its container. Gases have neither a definite shape nor a definite volume. In this state, the constituent particles are far apart and move freely. Now, let us do a sample drag and drop exercise to check your understanding. Put the following objects in the correct box. In physics, a state of matter is one of the distinct forms that matter takes on. Each of the states is also known as a phase. Elements and compounds can move from one phase to another when specific physical conditions change. Drag the labels which suit into appropriate groups and click Submit button to verify the answers. The state of the matter refers to the group of matter with the same properties. Now, let us perform an activity to identify the shape and know the volume of liquids. Click each tab to know more. Collect different containers of various shapes like beaker, conical flask, and cylindrical jar. Take some water in a glass. Pour the same amount of water in each container. Mark the level of water and observe the shapes. Repeat the same process with milk and oil. Observe the shapes. In this activity, we observe that liquids take different shapes based on the container, whereas the volume remains the same. Finally, we learn that liquids have no fixed shape but have a fixed volume, and also liquids can flow easily from one container to another container. So liquids are also called fluids. Let us know about shape and volume of gases. For example, we know that compressed natural gas or CNG is a natural gas under pressure which remains clear, odorless, and non-corrosive. CNG comes into the filling station via the natural gas pipeline. The station has a compressor unit that compresses the gas where it is stored in a high-pressure tank for further use. It is passed from the tank to a CNG-equipped vehicle. Vehicles can use natural gas as either a liquid or a gas. In vehicles, CNG is stored in thick-walled steel, aluminum, or composite tanks built to last more than 20 years. From these observations in daily life, we find that CNG and all other gases neither have a fixed shape nor volume. Now, let us perform an activity to understand the compressibility of different materials. Click each tab to know more. Take a 100 ml syringe. Draw the piston to suck in air. Put your finger on the nozzle. Now press the piston. Observe the depth to which piston moves into the syringe. Repeat the same procedure with water and sand. Similarly, observe the depth to which piston moves into the syringe. From the above observations, we find that gases are highly compressible as compared to liquids and solids. We learned that mostly gases are used for cooking, LPG, and in many automobiles. In all these purposes, large volume of gas is compressed into cylinders of small volume to make them portable. Now, let us perform an activity to observe the diffusion of gases. Click each tab to know more. Take some incense sticks and smell their fragrance. Place them in any corner of the room. Light the incense sticks. Try to smell their fragrance from a distance. In this activity, we observe that when we light the incense sticks, the scent in the vapor form and smoke mixes with the air and moves across the room to reach our nose. Finally, we learned that the movement of air, vapors of scent, and smoke is known as diffusion. In this case, smoke, vapor of scent, and air are highly mobile and are in the form of gases. Let us perform an activity to observe the diffusion of particles of liquids. Click each tab to know more. Take 2 beakers, fill them with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Take a dropper. Now add a drop of potassium permanganate solution slowly along the side of the other beaker. Observe the changes. In this activity, we observe that the particles of potassium permanganate and water spread and mix up with each other on their own. Finally, we learned that the particles of potassium permanganate and water move. Therefore, we can conclude that liquids also diffuse with each other like gases. Let us know about the diffusion of solids, liquids and gases. We know that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. Carbon dioxide diffuses from blood into lungs. Solids, liquids and gases diffuse into liquids, and rate of diffusion of gases is higher than that of liquids or solids. Let us do a lab activity to observe the speed of diffusion of two gases. Click each tab to know more. The aim of this activity is to observe the speed of diffusion of two gases. The materials used in this lab activity are glass tube, rubber bung, ammonium solution, hydrochloric acid, pieces of cotton. Take 2 pieces of cotton wool. Soak one cotton piece in ammonia solution and the other piece in hydrochloric acid. Take a narrow glass tube. Insert both cotton pieces separately at the 2 ends of the glass tube. Now close the both ends with rubber bung. Observe the changes. In this activity, we observe the formation of a white ring from the least distance of piece of cotton with HCl solution. Because the hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Thus, we learned that the both gases react together to form a white substance called ammonium chloride. Therefore, we can conclude that HCl is more dense than NH3 because NH3 travels a farther distance than the HCl in the same period of time.
Knowledge check. Attempt the following questions to check your understanding.